Okay. Direct variation is when we have a function that looks like this, y equals k times x. It's kind of like the equation of a line where it just y equals mx plus b, but k is the slope in this case, and there is no b. All right, so that's why we say it's directly proportional. Did you do these in Algebra 1? Do you remember?
No.
Okay.
No,
Did this in
never.
Algebra 1?
Did you?
I don't know if we did in Algebra 1. Yeah, so basically when it says y varies directly as x, we know it's going to be y equals k times x. And it says y equals negative 15 when x equals 5. So we're going to take that first part. So negative 15 is equal to k times 5. So what does that give us for k?
-3.
K equals negative 3. So, what? No, I did say no. I just said we're using this information. Use this to find k. Okay, so now what do we... So basically the relationship is y equals negative 3x, right? Y equals kx. We figured out what k is. K is negative 3. Do you have a pencil?
And then x is 3. So then plug it in.
Yeah, so here's what we want. We want to find y.
Y equals -9.
That's it.
Oh, that's really easy.
Yep. Okay. All right. Joint variation is when you have two variables that are multiplied to k. Okay, so y equals k times x times z. So we call that joint variation. So it says, oh, okay, y varies jointly as x and y. So that means y equals k x z. So it says find y when x equals 10 and z equals 5 if y equals 12 when z equals 8 and 3. So we're going to use the second part of the information because this is what we weren't trying to find. Does that make sense? So when y equals 12, you're literally just plugging things in. So 12 equals k times 3 times 8. So we get 24k is equal to 12. What do we get for k? 1/2. Okay, and now what are we finding? Y. When x equals 10 and z equals 5. So just go back and plug in.
Y equals 10.
So 1/2 times 10 times 5.
Y equals 25.
25. So basically what you're doing is you're taking part of the information to figure out what k is, and then going back and plugging in to find out the other missing piece. Because it's k times x times z.
Now I get it.
It's
Oh wait, when y equals 12, z
because it's
equals
y
8.
equals 1/2 x times z.
Oh, but then you want to find.
We're finding a new value of y. So it's like we're finding a new value of y based on new information, but the k is going to stay the same. Yes. Okay.
Sure, so I can't say I understood the first problem.
Oh, she loved it. You know, Anne loved it.
Okay. Inverse variation. Last one. Inverse variation is when we just have y equals k over x. So directly proportional was k times x, right? This was y equals k times x. That's direct. Jointly is two of them multiplied. And then inverse is when you have k divided by x. So if x varies inversely as y, and we know x equals 24 when y equals 4. So we're going to find a new value of x when y equals 12. So using this information, we're going to figure out what k equals. So 4 equals k over 24. So
Why are you using?
Multiply 4.
K equals.
Yeah, multiply 24.
So 24 times 4 is 96.
96 equals K.
Right, so now we have our new equation, y equals 96 over x. So now we're looking for a new value. We want to find x when y equals 12.
Divide,
So 12x equals 96. So what's x equal?
8.
8.
So first you find K before you do that.
Yeah. And I'm going to skip these.
Is that then we're done?
Yeah.
Oh, wow.